If I do 400 joules of work to lift a 15 kilogram object, how high did I lift it? So this is a situation I think I can draw fairly simply. I'm just going to draw a sketch kind of off to the right here. So here's an object, and I'm lifting it up to some other spot, right? So here is that same object. It may not wind up being drawn exactly the same, but roughly the same. There it is. And so I'm thinking about what's happening here to this object. I'm going to think about this object as initially basically having no energy. And then up here, so this represents final, right? And I think there it's going to have an amount of energy that corresponds to mgh. In other words, I raised it up by a height, and that represents a gravitational potential energy. And it turns out that I mentioned in the key concepts that it's important to define the system. So I may as well talk about that a little bit here, because I could say like, well, okay, we're just talking about some object here. So the system obviously has to include the object. But if I'm going to include a mgh type of energy, I need to actually think about gravity being internal to this system. And that's maybe a little bit weird maneuver. We're going to explore that in some other examples in more detail, why that needs to be the case. But I'm going to say it's the object plus gravity. Since I assume it started at rest and at ground level, the initial energy is basically equal to, I'm just going to write 0 here. And I'm just writing this up to help me sort of understand some concepts. And then the tool that I said I would use is work is equal to a change in energy. And in that sense, since work is equal to delta E and it's final minus initial, and that's mgh minus 0, I think I can just say work is equal to mgh fits this situation as a more specific formula. And there will be other problems where sometimes we're going to go back in the definition of work, but when I look at what's given to me here, we're given a work of 400 joules at 3 sig figs, that decimal point is meant to indicate. And we're given a mass, of 15 kilograms. And in that sense, okay, I'm given this one, G is 9.81. Wouldn't it make sense if I could just calculate the height by dividing both sides by mg? And then when I put the numbers in for that, I would get 400 joules divided by 15 kilograms times 9.81 meters per second squared. So when I put these numbers into the calculator, I get 2.7183, etc. But maybe I can just round that off to 2.72. And I think since, right, this is joules, which is like newtons times meter, kilogram meter per second squared is a newton. So I think just the meter is going to survive that. And that makes sense because I'm calculating a height. So I wind up getting 2.72 meters.